Of 1.5 symbols, formulae, and equations. So we've looked at ionic compounds made from one metal and one non-metal. Now we're going to look at ionic compounds made from one metal and more than one non-metal. So how do you know when you have that? So if we go up here, there's a few key things here. We have looked at things like magnesium chloride, lithium oxide. You can see those on the screen. Okay, so they end in IDE, and that's our the key for us, that there's only chlorine present. Okay, if it ends in IDE, you just have the name of the metal, which it doesn't change in the compound, and then the name of the non-metal, which changes to an ending of IDE. So oxygen becomes oxide, chlorine becomes chloride, fluorine becomes fluoride, nitrogen becomes nitride, sulfur becomes sulfide, and so on. All right, IDE. Now the exception is hydroxide. So we'll come across that in this next part, because actually hydroxide is made from hydrogen and oxygen. So it qualifies for the next thing, which is ionic compounds, or compounds formed from a metal and more than one non-metal. Two plus non-metals. Okay, so how do we name these, right? First of all, how do we know that we're looking at such a thing? So they will end in ATE. Okay, so magnesium, for example, magnesium sulfide has got just magnesium and sulfur, and in a 1-to-1 ratio, because it's group 2, group 6. Whereas if we have magnesium sulfate, something else is going on here. Now, traditionally, the ATE ending tells us that we have sulfur and oxygen, okay? However, you do not want to look at those separately. So I'm going to switch over to the periodic table camera. So what we've got, if you remember our periodic table, so if you look here, you've got sulfur and oxygen and they're in the same group. So you might think, oh, magnesium, sulfur and oxygen, okay, we're going to look. No, if it ends in ATE, right, sulfate, you switch over to the back of the data leaflet. That here they are, right, and you look for anything. You see the way all of those except hydroxide, which is our one exception, all of those end in ATE. So you need to go there. If it's anything ending in ATE, you need to use the back of the data leaflet to work out its formula. So how do we do? Okay, so let's look at magnesium sulfate. So it's kind of similar to what we've done. So I'm going to just leave that there, right? So I have it handy. Okay, so we've got magnesium. How do we work this out? Sulfate. Okay, so what have we got in it? So we're going to do the same as we did before. We're going to put in the formulas of what we've got. Now, actually, I'm going to talk a little bit about the formulas of the ions and the charges, because this causes some issues. So then I might just get that far. So what part of what we've got here is the charge and what is the formula? Okay, so when I'm talking about formula, I'm going to highlight for each of them, because this causes serious bother. So I'm going to highlight the charge. So butanoate has a charge of minus, carbonate has a charge of 2 minus, dichromate has a charge of 2 minus, ethanoate has a charge of minus, hydrogen carbonate has a charge of minus, hydroxide has a charge of minus, methanoate has a minus charge, nitrate has a minus charge, propanoate is minus, sulfate is 2 minus, and sulfite is minus, 2 minus. And what is the formula? So you cannot, when you are doing these, do not fiddle around with the formula. So you need to consider everything in that box. And so we're going to come back to this. So I'm just going to box a few of them, because actually we won't come across many of them. This one we will, a lot. This one we will, a lot. And the last one we'll see a lot of is this one. Okay. So actually I'm going to rub out. You won't have to worry about that one until next year. Or dichromate, actually. Okay, so I'm just going to box really common ones that you're likely to have to use in the exam. So, magnesium sulfate. So, zooming back out a wee bit. Magnesium sulfate. So, if you look at the first thing is magnesium, you look on the front of the periodic table, and it is, let's see, chemical formula Mg. Now, the sulfate part, we need to take this off the back of the data leaflet. So, the formula of sulfate is SO4. Now, consider that as, I'm going to box that because you cannot, right? The 4 is not going to change. That's what people tend to disappear. So I'm just going to actually box both of them, because your formula is going to be, you're going to have something here, right? And something here, or maybe nothing, depends on what you have. So let's have a look at going through this with these ions. I'm going to rub this out for a minute. Now, the next thing we look at is the charges on each of the ions, right? So magnesium is group 2, so it has a charge of 2 plus. And just to remind you how I know that, if you go up here, remember we have a group magnesium, there it is, we've used it before, has a 2 plus charge because it's group 2, loses 2 electrons from a full outer shell, which is stable. And we're going down to, okay. Now the sulfate ion, its charge is on the back of the data leaflet. So it's what I've highlighted in orange, and hopefully you can see that's a 2 minus. So just double check your own periodic table. So I'm going to put that in as, let's put it as green. Okay, so it's 2 minus, right? Okay, so now we're going to do the whole thing of losing the charge, dropping and swapping, right? So lose the charge, drop, swap, and do that. Yeah. If you were paying attention, you'll know that actually they'll cancel out, actually, before you even have to bother with this part. Okay, so we're going to drop it and swap it. So it's Mg2SO42, but if you remember that if they're the same number, they'll cancel out. So we end up with a formula with just MgSO4, and when we put them together, without the boxes, the formula of magnesium sulfate is MgSO4. Now, let's have a look at sodium hydroxide. So again, going to the table. So sodium is group 1. So there's sodium in group 1. So it's got a charge of plus. It's going to have a plus charge because it's group 1. And so let's do its formula first. Na, I'm going to box it. Hydroxide. Now hydroxide, although it doesn't end in ATE, it's the only exception, right? So it's on the back of the data leaflet. So its formula is OH, right? And now we're going to put in the charges. So this is plus, OH is minus. Okay, we're going to lose the charge, drop and swap the number. There's no numbers to drop and swap. And we'll take the boxes away, put those together, take away the boxes, and sodium hydroxide is Na and OH. So it's got a sodium cation and a hydroxide anion. Okay, let's have a look at another one. What about sodium sulfate? So again, we've Na and SO4. Okay, we've got the charge on sodium, this time is plus, and the charge on sulfate is 2 minus, as always. Okay, so we're going to get rid of the charge, lose the charge, drop and swap any numbers. This time we have a 2 here, so we're going to take that, and we're going to drop it and swap it to the 2, and then we're going to remove the boxes, and we have Na2SO4 is the formula of sodium sulfate. Now, what about magnesium nitrate? Okay, so this time it's Mg, box it again, and nitrate, you see that nitrate is NO3, okay, so I'm going to squiggle under there, so it's NO3, so I'm going to put a box around it just so you're not tempted to get rid of the 3. And now we're going to put in the charges. The charge of magnesium is 2 plus, the charge of nitrate is minus. Hold on there 2 seconds, I'm making a video for you, actually. Pause. So it's nitrate. So now we're going to lose the charge and drop and swap the number. There's only one number to drop and swap. So it's going to come, oops. Going to drop and swap. Okay, so now what do we do? So let's have a look. What have we ended up with? MgNO3 2. Okay, that's kind of weird. So we're trying to say that we have two nitrates. So if we have two of these ions called molecular ions, we need a bracket around just to show that we've doubled the whole thing. So we're going to just put a bracket here for that. So that shows that you've twice what's inside the bracket. Okay, so let's just do two more and then I'll leave you some to try yourselves. Right, so what about aluminium carbonate? Okay, so now we have Al. It's on the front of the data leaflet. I'm going to box it again. Carbonate. Just squiggle under that. So it's a CO3. And bracket that. Oh, sorry, we're going to put that in the box. Now, charges. 3 plus, because aluminium is group 3. Carbonate is 2 minus. And we're going to use the charge. Oops. Use the charge. Drop and swap each number. So that's 3. We're going to end up with 3 carbonate. And 2 aluminium. And then again, because we have more than one carbonate, we have 3. We're going to have to use a bracket. So we're going to have Al2. It doesn't need a bracket because it's just a single element. And then we need CO3, 3, and we need to separate that all out like that. So that's the formula of aluminium carbonate. And one more. Let's see. What about how about what's the worst you can get? Okay. So I'm going to give you a couple to do. Pause and then see how you get on. So sodium carbonate. I'm using hydroxide. Aluminium nitrate. Potassium sulfate. Lithium nitrate. Okay, so pause the video, see how you get on with these following that process, and the answers will be there when you turn it on again, okay? That's the end of the video.